Alright, so we got 3 more to go. I'm hoping to keep these short and sweet because I know some of them are taking a little bit of time, so I'm just going to roll right onto it. So, number 11, bottle rocket application. Something kind of cool. I've never done these. I might have to try it just for kicks. The height and feet of a bottle rocket can be modeled by an equation, a quadratic equation, where time t is in seconds. And here's this particular case, okay? So h of t, and I know that the MCA review in this case says h of t, but in other cases it just says h. It's the same thing. Is equal to 160t minus 16t squared. Okay? How long will it take for the rocket to return to the ground? And what is the height after 2 seconds? So, I mean, just looking at this is just a bottle rocket, some water, and just... Okay, so I don't know how high it's going to get. I wouldn't think it would get too high, but really, once again, I've never done this. So here's the equation that we have. And when we say here, how long will it take for the rocket to return to the ground? Well, to return to the ground, then that means that my height is 0. So I need to replace my height with 0. And I'm just thinking through the situation, thinking through the scenario. I've got a bottle rocket. It's going to come up, come back down. 0. It's at no height when I start and when I land. Okay? So that's why the 0 is here. Now I got to look at this. Is there a common factor between these two things? Yeah. You got 160 and 16, so that's 16. I've got a t here and a t squared here. So I can factor out a 16t. What do I mean by factor out a 16t? It means that I divide this by 16t, I get 10. I divide this by 16t, I get negative t. Now I got to think about this. All right, so here, again, what value for t in this situation on the outside here will make this whole thing equal 0? 16 times what will equal 0? 0. 16 times 0, anything times 0, that's going to give me 0. So then that's the first value. And then what about in here? What value of t would make this in the parentheses equal 0? 10. So now as I look at it, this means, all right, so the time at which this rocket is on the ground would be at 0 seconds, which makes sense because it's on the ground when it starts. It's not already up here. It's down on the ground when it starts. And 10 seconds later. So this thing's going to be in the air for 10 seconds. Doesn't seem very long, but I wonder how high it will get. All right. So again, this is what I was just talking about with what do the different parts mean. So this way you can see, our rationale. So the zeros of the function indicate when the bottle rocket is in contact with the ground, just like we talked about already. So it's before it's launched, and then it comes back 10 seconds later. Okay, so 10 seconds after launch. Alright, so at what height will the rocket be after 2 seconds? All right, I'm going to scroll back up here and take a look at this. At what height will I be after 2 seconds? So that means that t is going to be replaced with a 2 here, a 2 here, and then a 2 that's eventually going to get squared. Okay, so that's what our function goes through and determines for us. What's the height dependent upon time? So substitute 2 for t in the entire function, and here's where we started. This is what happens when we go through and substitute. I'm going to take it slow here because I want to make sure that we fully do the order of operations, so extra steps will be done here that you probably won't. So as I look at this, there's nothing I'm going to do with this guy over here. That's just what it equals. Substituted my 2 into here, substituted 2 into here. Order of operations, deal with parentheses, don't have any. Deal with exponents, I got 2 squared. Okay, so remember I deal with the exponents first. Don't take this negative 16 times 2 then square it. No. Exponents first. 2 squared. 2 squared is just 4. You've got the handy dandy calculator so that you can go through, and now I only have multiplication left. 160 times 2, that's going to be 320. 16 times 4, that's just 64. And again, you have the calculator. So this is nothing here that, it's not rocket science, even though we are dealing with bottle rockets. Sorry, I'm tired. So after 2 seconds, 256. Wait a minute. 2 seconds into the launch, which means it's not even at its max yet, because the max should be halfway through. So the max would be at 5 seconds. At 2 seconds, this thing has already reached a height of 256 feet. If we consider a single-story building to be around 10 feet tall, this thing's 25 stories in the air after 2 seconds. I'm definitely going to have to try this stuff. Of course, make sure that I do it in a very proper environment so I don't poke anyone's eye out. All right. Hopefully this was helpful. Again, you can always review, go back. If there was a part you didn't understand, stop it, pause it, go back to where you lost track of what was going on. All right, 2 more left. See ya.